And so for the people that don't know which picture belongs to which name, I put them in order. And I will give you a brief introduction on SPARQL and RDF and how you can use that to query data. So yeah, what is SPARQL actually? SPARQL is a querying language. So it's a language to ask questions to a database that is defined into a certain format, and that format is RDF data. So if you want to understand SPARQL, you need to know some basics on RDF data, what that looks like, and how things are linked. And I see that my internet is misbehaving a bit. So I'm switching off my Wi-Fi and moving to this more stable connection, I hope. So let's have a look at RDF data first and how that information is stored and linked. So RDF is an abbreviation for the Resource Description Framework. And this is a framework or a format to express information about resources. And the resources can be anything. Can be people, documents, biological concepts, genes, proteins, you name it, you can put that into the RDF format. So this is an example with some images where we can see how data is linked into this RDF structure. So we have Bob here on the left, which is a person. And Bob also has a birthday, so he's born in 1990. And Bob also has a friend called Alice. And Bob is also interested in a painting, the Mona Lisa. And of course, you and me know that the Mona Lisa is a painting, but that information is actually not in this model. So that's something where a computer might go wrong and might not understand what the Mona Lisa is. So you would need to add some information on that. If you say, I want to have all paintings that are created that are liked by Bob, then there should be a link from the Mona Lisa to this is a painting. And of course, the Mona Lisa was created by a very famous artist, Leonardo da Vinci. So this is how the data is linked in RDF. So it's really about linking information together. And we can ask questions to this type of data. So one of the questions or queries that we could ask is, when was Bob born? Well, the information that we then need is Bob, and the relationship is born on, and then the date of birth of Bob. So we actually need 3 types of information to answer this question. Another question we could ask, which is maybe not the nicest question to ask, but still, does Bob have any friends? Well, actually, yes, Bob has a friend, and the friend of Bob is Alice. Doesn't say about anything of Alice being a friend to Bob. So this is really, Bob has a friend that's called Alice. Then another question, so does Alice know a person that likes paintings of Leonardo da Vinci? So now you see we're already going into some more details, and that we're trying to link different types of information together. So what I did for this query, this question, I used some colors in the next slide to indicate what part of the question is where in this graph. So does Alice know a person? Yes, she knows a person because she's a friend of Bob, and Bob is a person, and is a friend of is kind of assuming that they know each other. And then the next part, that likes paintings. Well, like I said, we don't know if the Mona Lisa is a painting. That has not been mentioned in this database, but we can kind of assume that the Mona Lisa refers to that famous painting. And Bob is actually interested in the Mona Lisa. And then, yes, this painting has been created by Leonardo da Vinci. So here you actually see that these 3 items are all needed to answer this question. And there also needs to be overlap between these items, because if I would ask a certain question and there is no link to the next item, you cannot connect these 2 things together. So that's the main structure of the RDF data format. It's encoded into a subject. Then there is a predicate that has a certain direction, and the direction points to the object. So this is how RDF data is almost always linked. And this is an example again. So Bob is interested in the Mona Lisa. So in this case, Bob is the subject. He is interested in is the predicate or the relationship between the subject and object. And the Mona Lisa is the object. And this is also called triples. So the information in the RDF graphs are normally encoded in triples in the more basic RDF graphs. There are some that have more abilities to link data, but I think that's going a bit too far now for this basic introduction. So today we're going to work with Wikidata, which is a database where a community comes together to encode data on various objects into the RDF structure. So Wikidata is known for encoding the data that you add automatically in an RDF structure, which is different compared to other databases that we use. So now there is a different format that we then convert into RDF. And for Wikidata, this automatically happens. And that's why also I think this is a nice database to start with. The data is CC0 licensed, so anyone can modify it, reuse it in their own tools or their own software, and you do not even have to acknowledge Wikidata for that. Of course, it's better if you do, because then Wikidata also gets some credit and the people behind it for the work that's done there. But officially with this license, this is not needed, and you can just do anything with the data that you want to. And the data can also be added by the user community. So the moment you make an account on Wikidata, you can start adding data. And the nice thing here is if you write a query and you see that you're getting not a lot of results back, then you can actually go to Wikidata and make changes. And within a few seconds, the data is actually available for querying. So it's really fast. It's updated almost instantaneously to the database where you can create these queries, these SPARQL queries. And to understand how to query that data, there are some basic building blocks to build up the SPARQL query, which we will show you in the hands-on session. So this is how a Wikidata page looks like. And I borrowed this slide somewhere from the Wikidata documentation. It's also very well documented. So you can kind of find out anything you want to or need to on this data. So if you go to a page on Wikidata, and for example, this is for Douglas Adams, which has his own identifier Q42, then you can see what this person is or does. So he's an English writer and a humorist. There are also some aliases available, and these are available in various languages. And the nice thing here is because the community comes together, that you can get descriptions for, in this case, this author, but also for genes or proteins or pathways in various languages. And the human disease ontology uses property of Wikidata to make sure that their ontological terms were translated in several languages. And so that's, I think, one of the nice things about Wikidata, that you can also go to the native language of, well, basically anyone in the world. And then the information that is encoded in Wikidata in the RDF structure, that's all linked to this ID. So this Q42, that's the subject. And then the relationships or properties are here in the beginning, so educated at, and then the object that this relationship is linked to, these are listed here. So St. John's College and Brentwood School. There are also some qualifiers to describe where the data is coming from or give more detailed information. So in this case, you want to know from which time period this person was located at this school. And indeed, where the information is coming from is added in references. And you can actually go to Wikidata and look at this information yourself and directly see also for this item, for this subject, I have these relationship types available, and this is the data connected to it. So going back and forth between the SPARQL endpoint, where you can query the data, and the database itself, that makes it for me always really easy to see what information is there, what am I missing, how can I extend my query. So the workshop material is located at this URL, and I believe in the overview planning, there's also a link to this workshop material. We previously gave this at a different conference, BioSB, that's a Dutch conference, but the material should still all work and should also be relevant for you. And we're looking at some biological examples. And then the last thing I would like to end with is when you start with Wikidata, it's just a start. But what you can do is actually link the information from Wikidata to other databases. And in this case, I looked up a few biological databases that have data available in the RDF structure. And then you can go from Wikidata to one of these databases, multiple databases, or start from one of these and then go to Wikidata. And then you can actually integrate data of various different resources together. And this linked data approach is very powerful. But I have to warn you, federated queries can also sometimes take quite a lot of time. So then query optimization comes into play. And this is something that I'm still struggling with. So that's just trial and error, I think. So Wikipathways, that's one of the databases that our group is responsible for maintaining and hosting the RDF data. REA is a reaction database that links metabolites to proteins. And the proteins are actually coming from UniProt, the protein database. And UniProt also has quite a lot of data on different taxons, so different species that are available, and also the protein structures that are in there. So you can actually obtain protein structures for different species and then, for example, do a comparison over these references and maybe do a BLAST analysis if that's what you're interested in. And then the last one is Campbell, which has information on drug and drug properties. Even though they still provide their data in the RDF format, they do not have a live database anymore where you can query the RDF data. So you can either set it up yourself with the different graph databases that are available. But if you've never done that before, that's a bit difficult. So actually, Amar from our group, he made a mirror of that data, which is available at this link. So you can use this link to then try to query the data from the Campbell database. And this linking to other databases is done through so-called federated queries. So from Wikidata, there is a list of SPARQL endpoints that they link to and that you can use in their federated queries. And we also have some examples available in Wikipathways for some federated queries. But yeah, as I said, the Campbell database was offline for some time, so some of these are still under construction. And I think it's nice to see these examples where they are at and how they work, because that will help you to understand how to build these federated queries yourself. So at the end of this tutorial that we have available online, if you say, I actually wrote a nice query that I want to share with other participants, you can do that at GitHub. If you're unfamiliar with GitHub, you just need to set up an account, which is as simple as setting up a Facebook account. And then you can just add your query in a textual manner. And then maybe we can use that next time to help other participants to understand it. We also have an issue tracker on GitHub where you can ask questions or suggest improvements or things that you're missing for the tutorial. And that's it. So thank you all for your time. And now I think it's time to really get active with the SPARQL queries and see which different elements exist.